How do you split an atom?
So here's how it works. You have nuclear material, which in most cases is uranium-235. So the 235 isotope of uranium has fewer neutrons than the normal naturally occurring isotope, which means it's unstable. And that instability means that when you hit it with a neutron, it will split into fragments. And that explosion into fragments at the atomic level produces an enormous amount of heat. How do you make sure that those neutrons hit those atoms? Essentially what you do is that you assemble uranium into a certain pattern with what's called a moderator. So a moderator scatters neutrons geometrically. So there's sort of a configuration of moderator, which in our case is graphite. We use pure graphite. It's essentially crystalline carbon and uranium. And if you configure it the right way, you can model it where if a uranium atom splits, it releases a neutron, and that neutron will hit the graphite and it'll scatter around. And then it'll eventually hit another uranium atom. And that uranium atom will split, release 2 more neutrons, and those will scatter around. Hopefully those 2 will hit uranium. Those will cause 2 more splits, and so you have 4 neutrons, and then 8, and then 16, 32, 64, 128, 256, 512. That's an exponential growth function. So you have an exponential growth of neutrons that are essentially more and more neutrons scattering around inside of this graphite core, and the graphite is responsible for making sure they scatter back in to hit more uranium. And eventually you have heat production. That neutron production rate goes up, and the heat goes up. And so now you have a hot core. So what you do then is you take a fluid and you pass it through the core, and the fluid gets hot. And so you have hot fluid coming out of the reactor, and you can use that hot fluid for useful things. You can spin a turbine with it. You can create hydrogen with it. You can heat a home if you really wanted to. And so you cool that as you run it through something useful, and then it comes back into the reactor and gets heated up again. So you have essentially a heat loop, and you're heating it up with uranium that's undergoing fission in a nuclear core. Actually, mechanically pretty simple.